Hello everyone! Have you ever wanted to program a microcontroller with a language that's simple, powerful, and incredibly efficient? Today, I'm going to show you how I got Forth, a unique and versatile programming language running on a tiny and inexpensive HM-10 Bluetooth module. Forth isn't like C or Python. It's a stack-based concatenative language, which means you manipulate data on a stack. This makes it perfect for embedded systems because it's fast and has a very small memory footprint. Think of it as a language designed to give you direct control over the hardware. Now let's talk about the hardware. The heart of our project is the HM-10 Bluetooth module. These are super cheap and easy to find. Inside this little module is the Texas Instruments CC2541, a system-on-a-chip SoC specifically designed for Bluetooth low-energy BLE applications. The cool part is that the CC2541 uses an 8051 compatible core, which is a classic microcontroller architecture. This allowed me to adapt the CamelForth 8051 source code to run on this specific IC. So, how does it all work? I've wired up the HM-10 module to a simple serial to USB converter and connected it to my computer. Now, I can use a terminal program to send Forth commands directly to the microcontroller. Let's try a simple thing first. Here, I'm defining two new words called LEDON and LEDOFF. In Forth, a word is like a function. These words simply toggle on or off the status LED in the module that is connected to pin P03. But why stop there? Let's do something more advanced. I've also connected a MAX 7219 LED matrix display module which uses the SPI protocol. This is a perfect example of Forth's power. I've written a few Forth words to send commands to the display. And there you have it, we have full control over the hardware using Forth commands. This opens up so many possibilities, from creating simple robotic controls to building custom sensors. Thank you for watching, have a nice day.